Welcome to the EcuTek RaceROM webinar. This section deals specifically with the Nissan GTR.
Nissan GTR, flagship GTR. Drag and drop the ROM. No RaceROM feature file added at this time. Squash the map up. Hopefully you guys can see the screen properly, and we drag and drop on a RaceROM feature file. It's now been added. Incidentally, just when we drop this on, we do have to save the file before we program it in. We can't choose Tools, Program ECU. We have to save the ROM, and always give the ROM file a new name. I pretty much save ROM files with the RaceROM feature name in. So in this instance, I would save this file as maybe, I don't know, iteration. So RaceROM feature file, and it's revision 12.114, and then I would call it 001, and then save, and then that's my file name. And every time I create a new one, 001, 002, you guys know you're already doing it. So RaceROM feature files are available for the Nissan GTR. Now we have a current release feature file that's on EcuTek update from pretty much last August, version 2 RaceROM. That we're actually beta testing at the moment. We're about to do a long overdue release that's we've done a lot more development on. So some of the features that you see today on RaceROM GTR might not be what you've seen and what you've been using. I think it's better that we cover the new RaceROM feature file that you're going to be seeing rather than the old one that you have been using that we're not going to be updating. We're going to be updating shortly, so we've chosen to go with the new one. So first of all, Nissan GTR, the current RaceROM feature file has road and race, pretty much like the early STI did. We had two sets of map switching, requests from the customers asking for more maps. We've added now 4 sets of maps in for Nissan GTR. So we've got 4 map switching mode, and the map switching mode is indicated in 2 ways. It's indicated by the rev counter, like on BRZ86, so we drive the tacho, show which mode we're currently in. The map switch mode is controlled by using the cruise control, so we push and hold the cruise control button to enable map switching mode. We use the cruise control up and down, toggle to change between different RaceROM modes, 1 to 4, so 1000, 2000, 3000, 4000. If we leave it, it will save after about 2 seconds. If we push the button again, it will save it instantly. So we can map switch like in really 1 second. To use this RaceROM map switching indication on the rev counter, we do need to program the gearbox ECU with the latest RaceROM feature file. For technical reasons, basically when we're using the rev counter to indicate the current engine speed, driving along 2000 RPM, we map switch to mode 4. The tacho is going to say 4000 RPM. Sadly, the gearbox also thinks we're doing 4000 RPM, so we have to assist the gearbox ECU during our map switch mode so that the gearbox doesn't change gear, doesn't think the clutches are slipping. So if you don't want to program the TCM on the GTR to use this new feature, you simply don't enable the map switching feature, which is shown. Display map switch mode on tachometer requires TCM flash. So if you don't want to use the new map switch indication because you don't want to program the gearbox ECU, then don't enable this feature. It's not enabled by default. If you don't enable it, we also show which map switch mode you are in on the coolant temp gauge. So like with BRZ86, we can have 1 mode, no map switching, 2, 3, 4, choose whatever you want. And we can display which mode you're currently in on the information display on the GTR. The digital coolant temperature gauge will indicate which mode we're in. So maybe your coolant temp is currently 80 degrees. You enter map switch mode, coolant temp will say 1 if you're in map switch 1. You go up 2, 3, 4, coolant temp will show 4. Push the save button, and then you're now in map switch 4. While you're in that map switch mode, you can change that value that is displayed. using the coolant temp gauge values shown here. So you can have it that in mode 1 maybe you have 91 octane fuel, so mode 1 would show 91. Maybe mode 2 95 octane, mode 3 98 octane, maybe mode 4 85, so coolant temp would show 85 in mode 4 indicating E85. It would show 106 in mode 3 indicating race fuel. So it depends. You can either have standard 1, 2, 3, 4, or you can change the map switch modes to indicate the coolant temp gauge to indicate what fuel quality you're currently using. Okay, so map switching on map switching on GTR. We have the VVT back in. VVT makes a big difference on GTR. Advancing the cam timing from 20 to 30 degrees will make turbo spool better. Be careful, don't make the values too big. You'll get the black smoke coming out the back as the unburnt fuel just pass through the cylinders. But you can set it up so that you've got more aggressive spool on the GTR in different modes, hence the VVT maps are available for all 4 modes by default. Map switching, we have fuel maps. Now here you'll see the new what we're calling the high power fuel maps. We're no longer restricted by the puny factory ignition and fuel maps on GTR, and we have a much larger fuel map here giving us much larger in resolution at higher engine loads. So we've got 4 fuel maps for the 4 different modes. Injector end angle. So I'm not so sure this feature is going to stay in for the release version of this GTR RaceROM feature file. But this is the injector angle. The injector firing angle can be changed currently between the modes, but I think discussions we've been having with various people are going to pull these maps to save space in ROM so we can add other features. Also map switching, we got 4 injector flow scaling bytes. Now there is a factory default injector scaling byte that's in the software. It's not very useful. We can only go up to about 780 cc. Most people have put 1000 cc injectors. So using the RaceROM injector scaling, we can set different injector scale by in different map switch modes. I.e. we can do E85 tuning in mode 4, set the value accordingly, 25% smaller. Okay, fuel maps, map switching, that's fine. VVT. We have a torque map, so we have a new high power torque map. A lot of the problems with GTR come from engine load and MAF rescaling, make the torque map, the torque value that's supplied to the TCM, the gearbox ECU, inaccurate, causing things like clutch slip, poor gear change decision, too harsh on the gear change, being whacked in the back on a shunt, not good for the gearbox, not good for the drivetrain, all in all. New high resolution torque map now will keep engine load more accurate and keep gearbox control so much smoother. Vast improvement. Okay. 1 second. Right. So I'm just looking to see which other maps we have. Ignition. Did we do ignition on GTR? So ignition maps now. Some of you may well recognise map switching. 4 sets of ignition maps for GTR. So we've got 4 modes we can switch now. Biggest change here that you will see, 2 things you're going to see here. First of all, we finally got a regular ignition map, thanks to EcuTek RaceROM. Ignition calculation on the Nissan GTR is extremely complex, like most calculations on the Nissan GTR. EcuTek simplified this into a conventional ignition timing map now, where knock retard is applied after this calculation. You'll also see the engine load now goes up to 200%. This is around 1,000 horsepower now. A few people have been testing around 1,000, 1,100 horsepower, pulling 190, 200 engine load. So basically you're looking at 1,000, 1,100 horsepower map here. And much bigger than the standard Nissan map, 16 by 16. Can't remember quite how big we made it now, but certainly a big map, a lot of resolution, really, really smooth now. car drives super smooth with all this resolution, accurate calibration. We've set these standard values. It's not going to copy these anywhere from the factory ECU. These have been set by us, and when you apply the RaceROM feature file, will be written. They've been calibrated pretty much against a stock car, and from sort of tuning, typically for the engine load that you achieve, the ignition timer values you're going to get, but they're not going to compensate for things like poor fuel, hot climates, and premium markets like Japan, where they've got high octane fuel, where the car's going to take more advance. So you will have to calibrate these tables as per your local conditions, really, as always. So just because this particular ROM is a JDM ROM, so typically it would have more advanced than something like a US ROM file running, hot conditions, altitude, poor fuel quality. The JDM and the US card will be quite different, so it's important that you realise, just because you're using a US-based ROM, that the base ignition map that EcuTek show you is not going to be the same as what the factory car would run. Quite important to note that. Intake air temperature compensation, not calibrated at the moment, but we'll put some calibration in, so for high temperatures, high intake air temperatures that retard the timing, possibly add some advance at low air temps. Okay, ignition, fuel maps done, VVT maps, yep, all done. Looking particularly for the map switching. Yep, so I think that's pretty much for the map switching. We haven't added, like with the original STI, lots of maps for map switching, because a lot of the maps weren't being used by a lot of the people, so there's no point us coding this. They take up space in the ROM, they tie our code up, busy doing things it doesn't need to be doing. So with custom maps now, if you want another map specifically for per gear fuel enrichment, per gear ignition retard, you create the map yourself in custom maps, and you turn it on in whichever mode you want. Again, separate webinar specifically for custom maps, but just because we don't have a map switch map for per gear fuel enrichment or per gear ignition timing doesn't mean we can't do it. Custom maps allows you to do it in the way that you want to do it. You can base it against engine speed, vehicle speed, gear. The judgment is yours, really. Okay, so then on to the other features of RaceROM GTR. In particular, alternate temperature sensor scaling. You may think, why do we want this? Yes. Okay, so one of the problems with the Nissan GTR is the temperature sensor scaling for voltage input conversion to temperature is jointly shared by coolant temperature and intake air temperature sensor. With the GTR running speed density, we're able to import an aftermarket charge air temperature sensor. In particular, a few of the tuners are doing kits where they're plug-and-play harnesses. You can use a Nissan Duke boost pressure sensor in the charge pipe that will replace the factory boost sensor and incorporates very nicely an intake air sensor, a charge air sensor as such. Using the plug-and-play looms, you can replace the charge air, replace the intake air sensor with a charge air. Alternatively, you can put a separate standalone charge air temperature sensor into the engine ECU using what's the pressure? There's specific sensor that we can use to import it. I think it's a fuel temp sensor pin that's not used on most models. So we can import a new intake air temperature sensor. It doesn't have to be a Nissan sensor. It could be Bosch, could be whatever you prefer to use. As long as you know the calibration for it, you can enter the scaling here. It's your chance to put in a separate sensor and rescale accordingly, i.e. a non-Hitachi based Nissan sensor with a different characteristic. Okay, if you use this, you have to enable the special feature. So we go back to our enable special feature, and I don't see him on there at this moment. Where is he going? I might have to get back to you on that one. Looks like the enable this map is not in there, unless now it might be automatically enabled when we change the map. It used to be that we have to enable this, but basically this is factory settings that go in there, so unless you need to change this. If you do want to use this certainly in you doing the beta testing with us on GTR, just let us know and I'll advise you accordingly. So next one, RaceROM boost control, my favourite. So RaceROM boost controller is, a lot of people get a bit confused about priority, which sequence the boost control will be written in. The boost control will work from your standard target map. We've got a target boost pressure map, then the compensations, and ultimately RaceROM boost controller will be a maximum. So when we are running the car real time and we adjust the boost target up and down using the cruise control, the boost control will be the final amount. Just because we can go up to 1.5 bar doesn't mean we're going to get 1.5 bar. The maximum will still be dictated by other maps, like compensation maps for temperature and altitude, compensation maps air temp, and also the profile of the target boost map itself. If we have 1.3 bar in the mid-range, dropping to 1.1 bar at the top end, just because we go up to 1.3 bar with RaceROM boost controller doesn't mean we're going to have a flat 1.3 target all the way to the rev limiter. It's going to go up to 1.3 in the mid-range and it's going to drop back to 1.1 bar by 6,000 RPM. So RaceROM boost controller will be an absolute maximum, but it's not going to be the target if other factors are influencing it. So you can set the maximum allowed okay, let's get some more maps open. Hopefully you guys can all see it. So the boost target is set by the high boost target map set here. So we're no longer limited to the 1.5 bar and we can go 1.72 bar absolute. And then the boost target maximum allowed map against coolant temperature. So another RaceROM map. Basically, if we want to run 1.3 bar, we would put 1.3 bar and it will interpolate between 10 degrees coolant temp, 75 degree coolant temp, up to the 1.3 bar. So if we want 1.3 bar, we're not going to get it until 75 degree water temp. Incidentally, if you want to change the x-axis, the input, you can change it, edit, 60 degrees, done. So we'll get 1.3 bar. We'll be allowed 1.3 bar at 60%, 60 degrees, sorry, engine temp. Okay, so boost target. Now back onto our RaceROM boost controller. So the RaceROM boost controller, these are the minimum and the maximums that you can specify. We set them by default. The maximum allowed boost control in the current release patch is in road and race, I think it's 1 bar and 1.3. Now we've got 4 maps. At the moment it's configured 1 bar in mode 1, 1.3 bar in mode 2, 3 and 4. So we can set it so the customer can only choose so much boost pressure in each mode. It's up to you how you want to set these up. Minimum 0.5, just because we have to set a minimum, so we set it at 0.5. Most actuator pressures are only going to be about 0.6 anyway, so unlikely to be able to run 0.5 bar. Increment, self-explanatory. Each time we move the RaceROM boost control, adjusting the boost, it's going to move in 0.1 bar steps. Okay, for RaceROM boost control we also have per gear compensations, so we can run higher or lower boost in different gears in different modes. We've got 4 different modes, so again, depending on which mode you're in, you can change the boost target, you can compensate the boost target depending on gear and vehicle speed, engine speed, sorry, in different modes. Upshift multiplier, quite an important map. Not everyone realises the importance of this. Basically, no flat foot shift on the GTR because of the dual clutch gearbox. So every shift on the GTR is a full throttle shift. There are instances, certainly with the bigger turbos and certainly when you get over 1 bar of boost, where scenarios you're pulling a bar of boost, 6,000 revs, you change gear, you go into the next gear, the engine revs, say, drop to 5,000, suddenly the engine speed is reduced from 6,000 to 5,000 revolutions per minute. You will get a pressure spike. The turbo delivering X amount of volume of air, engine speed reduces, the boost will go up. During that split second of gear change, this wastegate multiplier can be used to reduce the boost spike during gear change. It's based against time period because as the turbos, as you start to fit bigger turbos, you will need to profile this on the gear shift. So first of all, you want to maintain turbo speed during the gear shift. You want to try and maintain boost pressure primarily. There will be a slight drop. You can profile this map to maintain the boost as smoothly as possible, and afterwards, if you do get a drop in pressure and then an overshoot, you can use the time periods to dial in this map to set it up. You know, spend the time, understand it. It can give you perfect boost control on gear shift no matter how big your turbos are. Okay, so that's USP, bit of a code name, upshift, God, I can't remember what the abbreviation was. We call it upshift multiplier. I'm not quite sure what the P was. Perhaps somebody will mail in and tell me what our abbreviation is. Probably in the manual for what the P stands for. Upshift prevention, possibly wastegate multiplier. I don't think so. Okay, so per gear, straightforward. Boost discussed, boost limit. So the factory Nissan maps are written in a type of code that means we very easily max out the values. It's very painful easy to work with. We have, we're going to improve the boost control further, but RaceROM boost limit. RaceROM boost limit is a copy of the factory boost limit map, but we can go past 1.55 bar. Pretty soon these maps will be the only maps you can adjust, so you won't get caught out by Nissan's 8-bit code. Boost limit resume, because when the boost cut comes in, i.e. the injector's cut, there needs to be a pressure that the injectors will restore. This is the pressure. So you hit the boost limit at 1.4 bar. At 4,000 RPM, the boost pressure will need to drop to 0.85 bar before the injectors will restore. Okay, so working through them now. So boost gauge, for the digital boost gauge and the instrument display, driver information system is it called on GTR, we can control the boost gauge. It's scaled to in metric to 1.5 bar, and we can use the multiplier and offset to offset that should you want to, various reasons. I think it's it might help the guys in the US running in PSI. We can put offsets in there if you don't want to rescale it. One of the best features really is the wraparound feature, which we're going to make mandatory. It will be set by default. So if we do go past 1.5 bar boost, if we are running 1.7, the gauge will literally wrap round. I'm sure we've got a video on the EcuTek YouTube site where we go past 1.5 and it just builds round up to 2 bar. So it's actually indicating vacuum, but the gauge has wrapped round past 1.5, half a bar extra, 2 bar boost indicating there, and as you lift off again, it just rolls back again. Great little feature, works extremely well. You can play with it and change it, map sensors, all sorts of things you can do with it to have it working how you want under boost gauge. RaceROM boost controller done. Per gear rev limit, straightforward, as per STI. You can stretch the rev limiter if you want. RaceROM, I'm just making sure we're ready for it. RaceROM, rev limiter, per gear rev limiter, as just discussed. We're just fixing a small issue with that at the moment. That should be fixed in the next day or two. Speed density is subject to its own. So let's go and do RaceROM launch control. So RaceROM launch control, a webinar for GTR is well deserved, just like for BRZ, so I won't go in immense detail, but the Nissan has got a special factory mode that a lot of people don't understand. It's got a special launch mode where the engine will be quite reactive, very reactive to the throttle, and the gearbox will be set up for special launch condition. During that launch RPM, initially it was very aggressive. The traction control needed to be turned off. There was various issues with the gearbox. We personally had an issue with ours that wasn't to do with launch control. It was to do with a nasty little transfer clip that cost a lot of money to have fixed. The launch control mode can be adjusted using RaceROM launch control. So the factory setting when it was reintroduced by Nissan after they turned it off is around anything between 3,100, 3,300, 4,100 I think from memory. Let's have a look actually. So this is a 2008 JDM STI. When we go to launch control RPM is 4,500 on our car by default. So once we go into the special launch mode and you know when you're in it, we can adjust this launch RPM, therefore adjust the launch torque, increasing and decreasing the torque, more or less slip, less stress on the drivetrain. And while we're in launch control mode, we can do certain other things to get the desired effect that we want. So while we're in launch control mode, bigger turbos, lots of horsepower, we can add extra fuel for engine safety. We can also retard the timing. By retarding the timing while we're in launch mode, we can kill the engine torque. We can drastically reduce the engine torque, therefore the load on the clutch packs while we're in launch mode. Also, reducing the torque will allow the engine to build boost, so when we do release from launch mode we've got more boost sat there waiting to go when the timing's piled back in. We can set the minimum and maximum launch RPM, stop the customer going too high with the RPM or too low with the RPM. Factory default set for 4,100, you might want to allow him to go up to 5,000, sorry, you might want him to come down to 2,000. Min max all configurable. The step we factory default 250 RPM when you adjust it, and also you can control the VVT. You can pull the VVT about to get more airflow through the engine without actually making the power, making the torque and loading the gearbox, therefore protecting the clutch packs and the drivetrain itself. Okay, so RaceROM launch control is default enabled in the settings. MAF swap is another functionality you see there in the special features. Certain manufacturers of intercooler actually swap the MAF banks, which was, I don't know if the design feature was intentional or not, but it can cause havoc when the engine ECU is looking at bank 1 but it's adjusting bank 2. So things like throttle control, air fuel sensors are all going to go up the wall. Will all go up the wall if the engine ECU is looking at the wrong bank. So be aware when you fit big intercoolers, is it going to swap the MAF banks side to side? It's fundamental and it's important that they work properly. If you're not sure, check with the customer or check what intercooler he's got installed. Forge Motorsport, I think, is the main one that does it. There might be others out there that do it as well now. If you do have one with a MAF swap, use the MAF swap feature so that ECU is looking at the right bank for the idle airflow balancing features like that, so it's looking at the right one. These new RaceROM feature files we've been developing literally since last August. They're going to be our phase 3. We're beta testing. We've got a few people who've been testing. It's easier for us to test with just certain people who are high volume users, use it a lot. They give good, accurate feedback, which is important for us. We want to get as many of the issues dialed out. You know, even little inconvenient things that you might not think are inconvenient, they are for us if we suddenly release something and we get it from 50 people on one day. So we're ironing out all the bugs, and then we're going to be looking for a team of beta people who, you know, with confidence that we can give these out. People are using them, they're not going to have some of the problems that some of the dealers have had to endure during this development. So if you're interested in becoming a beta tester, let us know. We will be sending a mail out. Should be in the next week now. To all GTR dealers saying basically if you've got access to it, if you've got a shop development car and you want to participate with the testing, let us know, and yep, we'll have you on board. So working through the special features, so the upshift spike prevention, this is USP, up spike prevention. This is the gear shift, controlling the wastegate duty during gear shift. Is on by default. It's very good. It doesn't really work until we go for bar boost because the way we've set the map up. At 0.9 bar, if you have a spike to 1 bar, it's not the end of the world. If you've got a stock engine and you run it at 1.3 bar, you don't want it overshoot to 1.4, 1.5 because that could be the end of it. So it's more configured for when you're running over really 1 bar. Map switching discussed. We need TCM flash on the new RaceROM feature files. RaceROM launch control on by default. Getting into RaceROM launch control is a separate subject. We've got some quite detailed information in the GTR help files. Don't just wait for the next webinar. The tuning manual has a lot of information. It's based on the release RaceROM feature file that's currently on EcuTek update, but and it's being updated at the moment for the new beta features that we're testing. But a lot of information on there on what launch control is. A lot of people don't understand it, how it works, and how you can improve on the factory settings, certainly by using the later software, the Gen 2 TCM software. Very important. I'll honestly say now, with our latest RaceROM feature files, our car has never driven so well. It's so smooth, it's fluid, it's just how the car should have left the factory. With the Gen 2 TCM software set up in the way it is now, and the new high-power RaceROM maps, the larger ignition and torque maps now, the control interpolation is really smooth, and it's never driven as well. Even with the speed density as well, you wouldn't know the difference between them. We can use things like the RaceROM boost controller as a custom map output, probably more for the custom maps discussion webinar, but we can do trick stuff with the RaceROM boost controller to control calibration. We can control VVT with the RaceROM boost controller for tuning, for calibration, things like that. More detail on a custom maps webinar. The launch control we did enable by default. So, valet mode. Okay, so valet mode, not something I tend to use very much myself, but apparently it's quite important in the States. So, yep, features here. The valet mode can be enabled now quite simply by just pulling the handbrake and putting your code in. We've also got various security features on it. The valet mode is okay, valet mode for parking in the US, but it's also can be used as an anti-theft feature for here in Europe. The valet mode can be set up against various factors, in particular the torque. So when valet mode's been enabled, maximum engine torque we can demand is 200 Newton meters. So if anyone is getting in your car, they're not going to have any more than 200 Newton meters. We put it against vehicle speed and distance traveled. So we can limit the vehicle, default settings we have here, 80 kilometers an hour. So 60, 55, 60 mile an hour, 80 kilometers an hour for 4 kilometers, for 3 miles. After 3 miles, it's going to interpolate between 4 kilometers and 5 kilometers, going to drop the maximum allowed vehicle speed down from 80 to 5 kilometers. Car will basically be crawling along. So from an anti-theft point of view, this can be used. So if somebody does steal your car, if you park it up at night and put it into valet mode, someone steals your car keys, going to get away from your house, but they're not going to get very far. So equally, for your valet mode, it can be set up for your parking at the restaurant, and again, limiting the torque. The reduction rate is a raw value, won't make sense to anybody, but it's the way that the torque reduction is implemented. Making this value smaller will make it more progressive, not as harsh. Making the number bigger will make it very harsh the way the maps are applied. And a backdoor code to get around the system should you forget how to set the code up. Okay, so leads us on to our final one. So RaceROM boost controller, boost gauge, boost count timing. Final one then, speed density. So after valued feedback, let's say, from our EcuTek dealers around the world, it was clear that they were pushing for improved functionality from GTR, and in particular from speed density. So EcuTek have completely rewritten the speed density now, and now offer a much improved, more familiar to some people, volumetric efficiency based speed density map. Calibrated, now very accurate, very good, works extremely well, I must say. Did show some weaknesses in our other system, so we thank people who have helped and endured our development on this feature. Speed density can be enabled as usual in any of the 4 modes. It can be enabled a speed density to run idle, low load and MAF-based high load, or flip it around the other way. It can also be used in hybrid mode, where you can set it to run over a certain boost pressure, over a certain RPM, over a certain mass airflow, or all or any of the above conditions. Speed density also incorporates a temperature compensation, air intake temperature compensation, and also there's a base calibration of what the speed density has been calibrated at, i.e. 20 degrees C. Changing these values will give a global factor, a global adjustment multiplier on the speed density table. So there's also the ability to use the fixed temperature. So by using the fixed temperature, speed density will be calculated against a set temperature. So if people use speed density and they don't use something like a charge air temperature sensor, like the plug and play kits discussed earlier for the Duke, works extremely well. The AIT, we can say that charge air temperature should be calculated from the IAT sensor, which is measuring CAT's charge air temperature directly, or we can say we're using the fuel temperature sensor input to calculate speed density against a aftermarket supplementary charge air sensor. So like discussed earlier, if you fit something like, I don't know, Bosch charge air temperature sensor, you can hardwire it straight into the ECU on the fuel temperature sensor. Set this box up, speed density is going to be against a standalone charge air sensor. So all your intake air temperature sensor compensations that have been set up by Nissan will be unaffected by any charge air temperature, i.e. heat soak after hot restart, those weird situations where charge air will be really high but intake air could be actually quite low. So quite powerful, set it up how you like. Again, speed density map now been calibrated to 2 bar, and the feedback that we've had, everybody's saying the same. Very good, very smooth, very clean, and with the new high-powered ignition and fuel mats, tuning is pretty much effortless for the higher loads now, because the resolution is there. There's no rescaling of the engine load parameters anymore, which completely messes up all the ignition timing calculations, completely messes up all the torque maps. The gearbox doesn't respond well. The new high power maps now just move straight on. There's no limit at 100 anymore, and there's resolution all the way up to, as I say, 1000, 1200. I think 1200 is the highest horsepower somebody's told me they've been running on it so far. So we're looking forward to getting this release, and good GTR. If you've got shop development cars and you're interested in helping in testing, let us know, and we'd like you to be using this and give us some feedback. So coming back, GTR does have custom maps now. This Phase 3 release now incorporates custom maps. A few people have been using it for some time. We've been doing some bug fixing. Lots of custom maps in there can be used for all sorts of reasons. We're going to simplify the boost control as well on the GTR. We're going to release this initial patch version first, and straight after will come the boost control iteration. We don't want to make too many changes at one time, so this will become released first. But using custom maps, we've been able to put in some very simplistic boost control, which is what some tuners have been requesting. Quite a few tuners have been using the factory Nissan boost control with great results, fully understood it, but it is a complex boost control strategy, and sometimes, you know, it's like being a tuner, you just want to get the car set up as quickly as you can, and you don't want to be concentrating on 3 different things: ignition, fuel and boost control. So by using custom maps, very quick and easy to hard code some simplistic boost control. Let's say we use RaceROM boost controller as the input, so we still have complete control of the target boost. We can set up wastegate duty output for the individual boost control. We can set up air temperature, atmospheric pressure compensations for wastegate duty, and we also can implement the proportional and integral components as well. Turn them on. You can turn it on and off in any modes that you want. Working extremely well, and we're going to hard code this in the next release of GTR RaceROM feature file. So anyone struggling with boost control, let us know. We'll again get you set up, using the new boost control, and then yeah, look forward to making your job easier, basically. Okay, so on GTR we've done speed density, custom maps, obviously subject all on its own, very powerful GTR, just like you guys who've seen it on BRZ already. The GTR, just like with the 86 BRZ, has a lot of custom data logging. The custom data logging parameters very quickly found by adding the origin tab, right click on the bar there, left click the parameters that you want, origin, save it, save ROM editor layout default, and that will appear each time you open the ROM. You can see here by ordering in units or name, the color indicates accordingly. Clicking on the origin, you can see the EcuTek custom parameters. These are parameters that EcuTek have added into the data logging. This is RaceROM feature file version 12114. It's important that when you program the ECU with a certain ROM file, that you open that ROM file for your data logging, and that's the same for you master tuners with the programming kits for the end users. Really important that the customer is using the same ROM file, that there's not mix match between the ROM file that's open for the login and the ROM file that's programmed in the ECU. Because every time we create a new RaceROM feature file, the data is unique. So we can see here, quick skip through them, AFR, that's the AFR from the factory AF sensors. It's got a certain scale factor applied at the moment that makes it read richer than the car actually runs. The car might be running 11:2, but the true AFR might be 11:1. We're going to work to improve that, and there's going to be, you know, you're going to need to watch out for it if you've been using the product for a while, but we're going to put a new rescaled, closely calibrated, more accurately calibrated AF sensor like that's on the Nissan Duke, let's say. AFR target. AFR target is a lookup from the fuel map. It is not like with the STI and the Subarus where the target can be incorrect. Because the GTR is closed loop on full power, this is going to be output of what your fuel map is. So on the GTR, if you fill it with 10:1, you're going to get 10:1. Your AFR target's going to say 10:1, and your AFR bank 1 might say 11:1, and your fuel trims are going to be adding plus 20%. The ECU is going to keep adjusting the fuel trim to hit that target AFR because it is a closed loop. Boost bank 1, boost bank 2, these are the pre-throttle boost sensors. We name them as boost sensors. They're pre-throttle, so they never show manifold depression. Boost error shows, again, as mentioned earlier, you may well have a target boost pressure of 2.2 bar, but you might only be getting 2 bar. Reason you're only getting 2 bar and your boost error says 0 is probably from a compensation factor. Boost target, again, very important for data logging. What is your boost target? Just because your target, your desired boost map has got 1.4 in it doesn't mean you're going to get 1.4. Look at your boost target. If you've only got 1.2, there might be a boost limiter, maximum allowed, something stopping you from going to 1.4 bar. Boost target, very important. First thing I do, support emails that come in with a log file, with a ROM file. I'll look at what's the boost target, what's the boost error, what is the manifold pressure at that point, see how tight the boost control is. Calculated airflow is based around the Nissan's factory boost control system, where Nissan calculate the current airflow and the difference of airflow that's required to maintain the current turbocharger speed. The desired turbine wheel airflow map again is related to factory Nissan turbo boost control, where they calculate the airflow required to keep the turbine speed constant. Engine load BFS, a lot of you guys will be familiar with Nissan's parameter called base fuel schedule. This is the engine load parameter that's base fuel schedule based, which is what some of you guys may be used to working with. Okay, gear. Standard Nissan parameters don't give gear. We tell you what gear you're in. It helps us for support, and it helps you guys supporting your end users if you're master tuners. Injector duty, how much injectors open? Pretty much with an exhaust on the car, you're going to max out the injectors. A bit of PR, bit of sales pitch, but EcuTek do have some very good quality 1000cc injectors for sale on the web store. You can buy them online, tried and tested for over 2 years now. Bosch Motorsport injectors work extremely well, going to do 900 plus horsepower and work extremely well. Okay, I'm being nudged with 2 hours. How?
Yeah,
I'm just going to
hour
give us a
time.
second. Are we?
Yeah.
Is it going to shut down?
No, I think we're just
Well,
losing
sorry
people.
guys, I've been rattling on a bit. Some of you people have probably gone home now or gone to bed. Not correction, not retired. I'm going to speed it up a little bit because, as I say, we want to do dedicated ones to certain parts and certain features of our products. So it will get covered in the future if you don't catch it now. Not correction, straightforward. Ignition retard, can't get it from Nissan. EcuTek supply it. Manifold pressure will tell you the it's the plenum-based map sensor in the inlet manifold. Mass airflow, Nissan use a percentage-based 0 to 5 volt and 0 to 100% output. You can log the output of each map scale. They're different for both banks. Torque actual is the actual torque output the car's running at the moment, not to be confused with the demand. Torque demand is what your axle pedal demands. Torque actual is the feedback based against mass airflow, therefore engine load, what the torque is. Turbodynamic sum, important for boost tuning, see how much the factory boost control system is compensating the turbine wheel map to hit the target boost pressure. And wastegate angle is the input to the wastegate duty map on GTR, which show you where you are and where the final wastegate duty lookup is coming from. So they're just a few of the GTR parameters. Again, we'll do a dedicated GTR RaceROM seminar, webinar, where we go in more detail with the GTR RaceROM product. We'll probably do that after we've released this new Phase 3. I apologise, I've been talking about the new Phase 3 because it's so close to release now, and this is what you're going to be seeing next. Most of it's a evolution of what the Phase 2 stuff you're already using, new and improved, we hope. Okay, so again, GTR has ROM security. Put back your stock ROM and you will be able to use other products. Just program back a standard ROM, and you have security on the TCM ROM as well to protect your work.